Hello, welcome. I'm Savalian. You may know me as the girl who has been doing Unity game development here on YouTube for the past few years, and in general for the past decade. So I've got a lot of Unity experience, but as you probably know, Unity decided to announce out of nowhere a terrible new payment plan. And while the plan itself was bad, the more important thing is that it revealed a lot of things about Unity's management and business values that are frankly gross. After everyone got mad about it, they have walked back their original plan slightly, to the point where now at least people who are stuck with Unity because they're too deep into a project or they don't have the funding to switch, they have the opportunity to finish their projects and get out, which I'm grateful for. But also, I'm not really convinced the original retroactive contract was even legal. So this compromise doesn't feel meaningful at all, and it definitely does not counter the fact that they thought this was reasonable in the first place. As for me, I am not beholden to any publishers. I have not set any release dates. I haven't even let anyone test my game because it's not really there yet. And really, I was just too pissed off and hurt to continue using Unity, so I won't. And it breaks my heart because I have always loved Unity. It's been a very indie-friendly engine up until now, and it's been an engine with a thriving community centered around education and accessibility. But the fact that they did this instead of just being honest about their business needs and developing a plan for increasing revenue that is sane shows that they were willing to exploit their customers if they could get away with it. They were willing to manipulate and potentially destroy the game developers that built their community that makes them so valuable. And that's not good. I'm not okay with that. So, I have started learning Godot, and this video is going to be the first video where I take a look at how Godot works, get my hands dirty a little bit, and I'm specifically going to be learning about Godot for 3D games. I don't really have any interest in 2D games, and it seems like the majority of the content and the general opinion around Godot is that it's good for 2D games, which is strange because so far, it seems that the 3D feature set is really thorough. I've been really impressed so far by what I've seen that Godot can do, and I was really worried going into it because of this general public opinion that Godot is better for 2D. I was worried it would be missing something really vital, and that I would have to go over to Unreal with my tail between my legs. But so far that is not the case. So far Godot looks perfectly adequate for 3D. So as an introduction to my little learning journey, I started by learning how to do some basic things in 3D, specifically importing a rigged and animated model from Blender, accessing different objects within the model, assigning materials, and setting up a system for playing animations that I can easily control from code. So we're going to walk through all of that in this video. The first difference between Unity and Godot is that while Godot can technically import FBX models, it requires a separate piece of software because Godot is open source, and it really works a lot better with a different format, GLTF2 format, which I had never heard of before, but turns out Blender exports to GLTF perfectly fine. So all the models I've ever made, I still have the blend file, and I can export it easily to this other format. It does also support importing a blend file directly, but I like to have a little bit more control over what I'm exporting because I do tend to put multiple different pieces of an object into one blend file, and I don't always want it to all be imported together. So I'm going to be doing the GLTF format. There are some special considerations here. The first thing, and perhaps the most important, is that I have noticed animations seem to export a little bit differently in this format. With FBX for Unity, I have been able to export all of the animation actions, and they would come in as their own tracks basically, even if they were all on the same NLA track, or sometimes even if they were not on any NLA track at all. But it seems like in the GLTF export, I need to actually create an NLA track for each one independently, and then export them grouped by the NLA track. And this is pretty easy to do, but it is another step that you need to do to get this ready. And there's another thing I noticed with animations that I can fix as I'm going through and creating these NLA tracks, And that thing is that with Unity, as long as I exported the model in its resting pose, all the animations would be sort of aligned correctly, playing on top of that base pose. With GLTF or Godot, I'm not sure where this sort of breaks down. It seems that when I do that, when I play the animation in Godot, it doesn't keep the unkeyed bones in the same spot the way that I'm expecting. And so it ends up being all wrong and getting really misaligned. So what I did need was to add initial and ending keyframes on each animation action for all bones. And so then it starts and ends in the same position, and those keyframes are maintained. So I think you can also bake the animation. I didn't want to do that. I don't usually bake animations, so this is how I'm doing it, and it seems to work. What this might mean, I'm not sure, is that it might not be possible to layer animations the way that you can in Unity, where you have certain parts of your rig that are animated and then you layer them on top of other parts. But I don't really use layered animations like this, so I'm not really worried about it right now. But if you are making something with a very complicated, like layered animation system, maybe something like a movement-focused FPS or an action game, this might be something for you to look into before you commit to using Godot, just in case it's not going to get you where you need to go. But to set these starting and ending keyframes, I just go into each action, go to the first frame, select all the bones, add a keyframe. I almost never make animations that change scale, so I just do location and rotation. I do this again at the end of the animation, and when I play this, it should look just the same as it did before, but now we have some extra keyframes to keep all the bones in the correct position so it doesn't get skewed when it's playing in Godot. Then to add the animation to the NLA track, we simply press this button push down, and it will push a track onto the NLA editor. And I'm in the animation view of Blender, and I've just added this NLA editor window onto the side. And then I'm just renaming the track so I can remember which one is which and move on to the next one. If I'm doing multiple animations, I'll also toggle off the check marks on the NLA tracks so that I can see the current action and play it and double check it without the NLA tracks playing over the top of them. And then because I've already textured, rigged, and animated this model, once I fix these animations, all I have left to do is export. There are a lot fewer options in here than for FBX, and I haven't had to do anything crazy with the scale or coordinate system. I've been using the binary option. I'm not totally sure when you would want to use the text option. It says something in the docs about being able to edit it later easier, though I'm not totally sure what all that entails. And previous models, I have included the materials in the export, but for this one I'm going to not include the materials because I usually do set up materials in Engine, and I have a material in Godot that I can use. I'll talk about that in a little bit. But by default, if you export with the material, it uses it as it is set up in Blender, which is very convenient, but because I am so used to configuring things in the engine and using custom engine-focused shaders, I haven't set up the Blender materials with the right stuff. I'm only using my albedo texture in Blender. I have metallic roughness, but I just never included it in any of these files. So I'm gonna exclude my material, but if you just leave it at the default settings, it will automatically combine the material into your exported model. I also prefer to only export deformed bones since my Rigify rig is pretty complex otherwise. And in the animation section, I want to uncheck limit to playback range and make sure that NLA track is selected so that all of those individual tracks have their own animation on them, and it should bring in the animation so that they are all separate so I can select and play them individually. Now, once I have exported this file, it's a GLB file. Importing is just as easy in Godot as it is for Unity. I can drag it into the file system window, which is basically the same thing as Unity's assets window, and it will do the import. And to get to this point, I really have just set up a new project after downloading the engine editor, and I've also followed the official Godot tutorial for 3D games a little bit, not all the way through. I got to the point where you start to think about creating mobs, and I sort of branched off to figure some things out on my own and explore some of this animation stuff, which they don't really talk about importing animations in the tutorial as far as I can tell. Once the model is imported, I can select it in the file system and click the Import tab to change some settings. I haven't had to change anything for my 3D models overall. The only thing I really need to adjust is some of the animation stuff. And the animation settings are in the advanced part of the import settings. There's a button at the bottom. Click advanced and it opens it up. And all I do for the animations is set the looping animations to loop by changing loop mode to linear. And I only want this on things like the idle or the walk, which should just keep playing forever. I also have a attack animation, and I do not want that one to loop, so I leave it as none. You also have the option here to save the animations to their own files. This may be useful if you're retargeting animations, which I haven't looked at yet, or if you have animations that, for example, are like clumped into the same file and need to be edited in the engine. I've read that that's how you can do that. But for me, I've exported these with the model I want to use them on, and they're fine just where they are. And that's really all I've had to do importing. The scale has been fine. I haven't gotten to the point in development where I'm thinking about LODs or light baking or any of the other settings here, so I've just left it all as default for now. And this is where things start to get a little bit different from Unity, and some of this stuff has been kind of hard for me to conceptualize, but I'll explain how I understand it the best I can. The first difference is that imported models are sort of forever kept in their own little bubble. They kind of look like scenes in Godot terminology, but they aren't editable the way that scenes are in Godot. And while Unity has scenes and then game objects, Godot uses scenes for the scene that you can drag stuff into, and then also scenes that you can save and include within other scenes. So, for example, if I drag the model that I've imported into the scene, we don't see all the pieces within. We don't see the rig. We don't see any like sub objects. It just has that top level scene. And then if I click the little button with it has like a play symbol on it, I can then open the scene and look at what's inside that scene. But if I do this with the imported GLB file, it will not let me make any changes. So instead of doing that, I'm going to right click on the model in the file system and create a new inherited scene. And what this does, it kind of creates a relationship between this model and a new copy of it, kind of like Unity's prefabs. So if I re-import the model after editing this inherited scene, those changes will cascade down and be in the inherited scene. And I actually realized after opening this inherited scene that I forgot to apply the mirror modifier in Blender, so only half of my deer was exported. So I applied that in Blender, re-exported, dragged it in, and it was updated. So I actually was able to demonstrate the inheritance right now, to show that as I change that original model, those changes will be present in the scenes that inherit from that model. Now, in Godot, instead of everything in the scene being a game object like it would be in Unity, they are all nodes. So if I want to explain this in Unity terms, in Unity, scenes and prefabs are both scenes in Godot, and then the individual game objects in Unity would be nodes in Godot. But it isn't a one-to-one comparison because we have to think about Unity's components or like scripts and things like that. Each of the nodes in Godot's hierarchy has a certain type, so they kind of act like Unity components. Each node's type includes certain variables, signals, which are like events, and then it has like functionality depending on what it is, like the camera node obviously acts as a camera, a mesh instance node renders a mesh, and things like that. And as far as I can tell, each node can only have one script attached. So if I want an object to have multiple scripts attached to it, I will need to add nodes within that hierarchy to hold those scripts and make sure that they are referencing the correct other nodes that they need to reference in order to do their job. So it's very similar to Unity game objects in a lot of ways, but it's also very different in how behaviors are attached within this hierarchy and how they relate to other nodes. To help explain, let's walk through the inherited scene from our 3D model. At the top we have a node 3D, and you can see what type of node it is by hovering and also looking at the icons. And as far as I can tell, node 3D is just a basic empty node that has a position in 3D space. If you click on any node, you can see the properties it has in the inspector, and you can also see the properties of the parent classes that this node inherits from. So the node 3D has just that position and rotation, and then node is what it inherits from, which is where you attach the script. Below that top level node, we have another node 3D that represents the position of the root of the rig. And then after that, parented to that, we have a new type of node, the skeleton 3D, which has all the rig data. And I kind of like this way of representing it. It's much tidier. In Unity, all the bones are separate game objects. It can be very, very busy and confusing. And here they are part of the skeleton node, and you can see the whole hierarchy. What I don't know is how to parent objects to specific bones at runtime, if that's something you can do. For example, like adding a weapon to be parented to the hand. I could definitely see something like that being useful, and I'm not quite sure how it would work with this, but I'm hoping that it is possible. Parented to the skeleton 3D node, we have our mesh, which is a mesh instance 3D node. This has a whole hierarchy. The mesh instance 3D is a type of geometry instance 3D, which is a type of visual instance 3D, which is a node 3D. So in all these inspector sections, we can see the properties for each of these levels of what kind of node this is. And then at the same hierarchy level as the skeleton, we have the animation player. If I click this, it brings up a window where I can preview all the animations that are in this player, and all of our animated actions, if exported correctly, should be in this drop down, and you should be able to preview them and even see all the keyframes, which is very interesting. And you'll see if you try to change some of these things and you didn't save the animations as their own file, you can't edit any of the options here, such as the length, whether it loops, or I'm assuming you can adjust keyframes, which is interesting. But for me, like I said, I'm going to do my editing of the animations in Blender, and then I'll just use the import settings to make it loop or not. And in order to get animations working later, I will need to save this inherited scene I've created. I'll just say this will save it as a scene, a tscn file, and at any point I can drag this scene into another scene, just like it was a Unity prefab. Next, we're going to talk about materials. Luckily, creating a material is very easy in Godot, and it's very similar to how Unity's default PBR material works. A material is actually a resource, not a scene or a node. I can create one by right-clicking in the file system, creating a new resource, and then in the window that comes up, selecting Standard Material 3D. I already made one and dragged all my textures in, so I'm going to open that one. But I'll show you what it looks like, and you can create yours as you need to. If you double click a material resource in the file system, you'll see all the options for the material in the inspector, and here you can adjust your settings, enable or disable different features, and get it looking just how you want. I have a set of textures that I made for Unity with albedo on one texture and metallic roughness on another. I did run into an issue with metallic roughness where I couldn't get the values working the way that they do in Unity. So in Unity, I used color for the metallic value and then opacity for the roughness. And here it seemed like something was backwards or something wasn't being applied correctly. I'm not totally sure what it was. I tried a few different channels. So instead of trying to make it work with what I had, what I ended up doing was changing my texture so that the red channel was the metallic value and the blue channel was roughness. And actually this works better for me because managing the opacity with just like GIMP and not like a texture creator was a little bit tricky. So I did have to change something to get this working, but in the long run it's going to be a lot easier because I can very easily set a color value much more easily than I can set the opacity of that color. I also have an emissive map that I added here as well, And that was the last piece I changed for the material. There are a lot of options here, so if you find that you need more control over how your material is rendering, I'm sure there's something in here that will get you what you want. I don't usually go too complicated. I don't do anything photorealistic with a lot of very detailed maps, so I'm probably not going to mess with most of this, but as I get further into my project and try some new things, I'm sure I'll work with some of it at some point. Once you get the material how you want it, you can open the scene where your mesh object is and drag it right in, just like Unity. So with this, we have our model in the scene and it looks how it's supposed to look. If you want to see your model running in a game, you will need to add a camera to the scene. You can preview models in the editor, but without a camera, it will just be blank when you run it. And there's just a camera 3D node that you can drop in here. You can use the camera preview option to move your camera around to line it up how you want it. You can also play with a world environment node to change how things look. This is the node that lets you adjust things like global lighting, the scene background, the skybox, and a lot of post-processing effects like glow and fog, two of my favorites. I added a bit of glow so that the emissive materials on my model actually look like they're glowing, and I played with the fog. I can't remember if I left anything on for the fog, but there's a lot of options in there too. Now, if you have a modeled 3D character, you probably will want them to animate. It took me a long time to figure out how to do this, and it's a little silly because in the end, it is actually very similar to how animations work in Unity. So we're going to go back to the saved inherited scene of my 3D model, and by the way, you can have multiple scenes open and switch between them with the tabs at the top. And remember, we don't want to open the imported GLB file, but the TSCN file that I saved, because that's the only one you can make edits to. And at the same level of the hierarchy as the animation player, and I want to add a new node that is an animation tree. This is basically a very, very similar thing to Unity's animator controller. It's a little different, depending on how you use it, it might be more or less similar, but it works much the same way and it has a lot of the same capabilities from what I've seen so far. In order to set up the animation tree, we first need to click next to tree root and add, what I'm going to add is a new animation node blend tree. And when we add this, it will give us a little workspace to add nodes to our animation tree. I also saw while running through this that there is a state machine in here. You might be able to get something exactly like Unity's animator controller with this, but I followed a tutorial that did it a different way. So I'm going to go over what I got working, and then we might come back to the state machine option in another video. And what I got working was the blend tree option. You also need to make sure you have connected the animation player so it knows where to grab the animations from. And then, this is important, if you want to see the animations play, you have to set it to active. I missed this step, I had no idea why nothing was working. You just have to activate it, that's all. And then those are all the options I set here. But once you activate it and you start adding things to your little space down here, you should see that it starts animating. In the animation tree editing space, you can right-click to add nodes of different types. As a starting point, I'm going to add some animation nodes. These are just the plain animation clips that you have access to from the animation player. The little film icon will let you pick which animation it is. And if you don't see anything here, make sure the animation player is connected in the animation trees inspector. From here, you can run these animations through other nodes to change them or to control which ones are playing or blend them. If you have directional animations for like movement that you want to blend in 2D space, there is a blend space 2D node. I don't have anything that complicated for this guy. I just have an idle animation, a walking animation, and then some like action animations. So first I run the walking animation into a time scale node, just in case I want to be able to increase or decrease the speed of the animation at runtime to make him walk faster or slower. And I can click the little dots to connect my nodes together to control sort of the flow of the animation tree. And then I'm using a transition node, which has a number of inputs. And then in code, you can set which input you want to transition to. And then that one is sent as the output for this node. So in the inspector, once you select the transition node, you can add inputs to it and give them names. I've added two, is idle and is moving. I've also named the transition node move transition, and the name of the node is important later. I'll also mention at this point that I am making a new animation tree for each character so far. There is a way to retarget animations in Godot, which I was very impressed to see that they had that as an option. But I don't have anything really set up for that right now, and so I haven't looked into it at all. But I wanted to mention it because it's cool and it exists. And if you aren't seeing any animations on your character in the preview, make sure you've connected something to the output node in your animation tree. For example, if I'm running through the transition, I want to connect the output of the transition to the output node. And then if I change the values of the transition right in the editor, I can see the different animations play. There are also one-shot nodes, which, as I understand, work a lot like Unity's triggers. They have two inputs, in and shot, and most of the time they just send the in animation right back to the output. But when they are fired, they send the shot animation, play it once through, and then return to the in. So it's very descriptively named, and to my eyes, it looks a lot like a trigger in Unity's animator controller. I'm not sure yet what the best way would be to set up animations with many different one-shots. I don't know if you just have to chain them all into each other in a system like this or do something else, but it's all part of the learning curve. What I have now is a tree where I can transition from idle to movement, and then occasionally trigger an attack animation to play instead. Also, I noticed there's a weird bump where the antlers on my deer model are weird at the end of the attack animation. I'm not sure if that was always there or if I did something weird in my export. Either way, it's not too bad. I'll fix it later. So our model is now totally configured, but it doesn't do anything in the game other than idle animation. So I'm going to run through some simple code to move around the model and animate it accordingly. And a lot of this code is directly from Godot's 3D project tutorial, so I'm going to direct you there if you want a complete walkthrough for a lot of this code, but I'll go through it and explain what it does. And I'm actually going to use the armadillo model as an example because I've already set up all of the nodes to fit how the script expects it to be set up. So it's already working, and I'm just going to talk through how I got it working. So as part of the tutorial, I set up a player scene where the base node is a character body 3D, which is a node that has some functionality for moving character meshes. The tutorial then had me add a node 3D under that for the pivot point, and then I added in my scene, which had the model, and this is the inherited scene that I made the animation tree changes to on it. And then the player also has a collision shape 3D, which has a sphere added as the shape. And in order to handle inputs that we're going to need to move it around, you do need to configure inputs in the input map. So this is project settings, and then there's an input map tab. You can add actions here or inputs here, and then click the little plus on it and give it a key or a control that you want it to use. Give it a name, and you're good to go. I followed the tutorial to create inputs for forward movement, backward movement, left movement, and right movement. And it's important, remember what you named these so that you can reference them in code. Then on the player node, so the very top level node of this scene, is where I attached the movement script. You can edit code directly in Godot, but it doesn't seem like it has any IntelliSense or autocomplete, so I connected Visual Studio because I can't do anything without IntelliSense working. I'm simply incapable. It was really simple to add Visual Studio as an editor. It's in the editor settings in the editor menu, and you can select the editor you want to use from the drop-down. I have noticed that sometimes Visual Studio doesn't want to open the first time. I don't know if maybe my Visual Studio is out of date or if the connection is just buggy. Sometimes I have to force close it and open it again. It's not too big of a pain, it's just a little bit weird. And as I said, a lot of this code was pulled straight from the Godot tutorial, but at the top we have some variables for speed, fall acceleration, and target velocity. And then we have our first function, which is a function we are overriding on the character body 3D. It's physics process with an underscore in the front. And I should mention I'm using C# because it's what I'm familiar with, If you are using Godot script, the process for your script will be very similar, but the syntax will be different. And this physics process function accepts a double for the delta, the amount of time that has passed since the last physics process. We set the direction to a 0 vector 3, and then we use input.isActionPressed with the name of the action passed in there to see which of our 4 directions are being pressed, and then we add or subtract from that direction vector as necessary so that we end up with a vector that is pointing in the direction that the player is using input to put in. If our direction is non-zero, we normalize it first, which just means taking that vector, keeping the direction it's pointing the same, but setting the length to 1, and then we rotate that pivot node that the model is attached to so that it faces the direction that we're going. Next, we get the velocity first by multiplying the relevant direction axes by the speed, and then we check if we're on the floor or not, and this is a built-in character 3D, what was it called? Character body 3D function. If we are not on the floor, we adjust the y velocity based on our falling acceleration. And I noticed that the tutorial does not set the y velocity to 0 if we are on the floor, and it was interfering with my velocity checks. So I added this else to the if statement that if we're on the ground, it sets the y velocity to 0. Then in order to actually do the movement, we set the velocity. And velocity is another variable that's just on the character body 3D node. And then later we use the move and slide function to actually do the movements in the scene. But before the move and slide, I have the animation code that I added. The way that this works is that first we get a reference to the animation tree. You can use get node, give it the type animation tree, and then you use a path relative to the node that the script is attached to. So for where I put this script, the path is pivots, and then the model name, and then animation tree. If your node names are different, of course, your path will be different, but Godot also has a handy feature where if you go into your 3D view and right-click on things in the hierarchy, you can copy the path to them. Next, I check the velocity length to see if the velocity is greater than 0. Length squared is slightly more performant to calculate, and I know that a 0 length is also going to be 0 if it's squared, because 0 times 0 is 0. But if you ever need to get the exact length for some reason, you will want to do length instead of length squared. If the velocity length is more than 0, we know that the character is moving in some direction. So in this one, I want to set the transition to the is moving animation. And for this, we use our reference to the animation tree dot set, and then in here we pass the path to the parameter that we want to set. And for this one, it's parameters slash the name of the node, which I named move transition, and then slash transition underscore request. And I grabbed this path information from the Godot docs. So that's where I got this transition request part from. And then the second parameter is a string for the transition we want to request. So is underscore moving is the one for when we want to play the walking animation. And then is underscore idle is for when we want to do the idle animation when the velocity is 0. So this should work, but we also have our one-shot animation. And I didn't actually set that up before recording this. I didn't do this for my armadillo. So I'm going to add that now. I will need an input to trigger this animation, so I'm going to add that now. I'm going to add E as an interact input, so it's called interact. And I can do that right in the input map, and then when I click this plus, if I just type E, it'll pull up the E key, and I can select that. And then back in the code, we need to use something to figure out if the button was pressed. You might be able to use is action pressed here, but what I'm thinking is what will probably happen is it will just re-trigger the animation every frame that they hold the E key down. So what I'm actually going to use is action just pressed, which in theory should only trigger on the frame where it is pressed, and then it won't trigger again after that until they let it go and press it again. So if is action just pressed, I pass in the name of the input that I want to check for. And then within this if block, I can use the same AnimationTree reference, .set, but this time we send the path parameters, the name of the one-shot node, which I just left as one shot on this one, and then instead of transition request, this one is just request. And then the second parameter of this one, instead of a string, is actually an enum that's part of this one-shot class, and it's going to be the fire entry. And I want to cast this to an integer because the docs told me to. And then the enum is animation node one shot request dot fire. And then there's a couple of different requests. I think these are for like canceling a one shot that's been activated or fading it out or things like that. But I just want to fire and let it play, and then it will go back to the regular idle or movement animation. Now let's run the game and see what we've got. And there it is. It's all working as expected. If I click E, it plays that attack animation once and then goes back to idling or moving, whatever I'm doing. It is very funny to me that the deer is so much smaller, and the reason that this happened is just because the armadillo critter was the first one I made for my previous game, and I hadn't really dialed in the scale yet. So the armadillo is huge, and then all of the rest of the critters are actually like a normal size. But I've got my movement. I rotate. The walking animation plays when moving, it stops when not moving. All of that's working, and it was pretty simple to set up. This is all the basic 3D stuff working. It took me some time to understand nodes and the way that things are structured in Godot, and now that I'm getting my hands on it, I'm finding that Godot is a lot more powerful than I expected, and I'm feeling pretty good about my decision to start a new game project in Godot. So far it's been a really pleasant experience, but that's all I've got for today. I'm sure this video is plenty long enough. We'll see when I'm done editing. Coming up will be more videos, probably similar to this one, where I go over some of the features I'm learning how to use with Godot, and then soon I'm hoping to start designing my next project and getting started on some dev vlogs for a fresh, clean game, all done in Godot. So I hope this was helpful. I am a super beginner to Godot, but if you have any questions, go ahead and ask in the comments and I'll do my best to find an answer. I am Savalian, and I make videos about games, development, and creativity. So if you're interested in any of that, please subscribe, because I'll be back soon with another video, and I hope to see you there. Alright, bye bye!